Hi, good morning, everyone. Good morning. おはようございます。おはようございます。Hi, I'm Ayaka. Ayaka と申します。今日は日本語と英語と両方で話しさせていただきますのでよろしくお願いします。しかし、Swift コードの部分は共通語なので英語で説明させていただきます。Today, I'm going to be presenting in both English and Japanese. So if you're wondering why you only understand half of it or why I'm saying everything twice, that's why. And however, for the code, I'll be explaining everything in English because Swift is a universal language. All right, so we have a lot of stuff to get through today, so let's get started. So one of the first talks that I watched after Swift was released is this talk by Gary Bernhardt called Boundaries. You might have heard about it from another talk, probably a functional programming talk. Gary Bernhardt さんの Boundaries の講演ご存知ですか？ファンクショナルプログラミングの講演でよく参照される講演です。In his talk, he presents a dichotomy of parts: the functional core and the imperative shell. So the idea is that you can make the core of your app functional. So that is, it's all input-output and no side effects, and it's much easier to understand. But not everything that we have to deal with is functional. Most of us have to deal with UI kit on a daily basis, and that causes all sorts of side effects. Even networking code, that's inherently side effecty and stateful. But the idea is that we can pull this out into a separate layer, imperative shell. この講演では Functional Core Imperative Shell のコンセプトが紹介されます。このコンセプトはまずコードの芯をファンクショナルにするということです。ファンクショナルにすることによって副作用がなくテストしやすいコードを書くことができます。しかし、すべてをファンクショナルにすることは無理です。例えば UI キットを使うと副作用ばっかりです。API を使ったネットワークコードもそうです。しかし、その副作用だらけのコードは Imperative Shell に引っ張り出すことができるということです。So when I was learning about this idea, this is how I've pictured things. イメージするとこんな感じです。ファンクショナルで堅実な芯です。This Voltorb here is a nice functional immutable specimen. This is how I imagined what a functional core looks like. And if you extend this to an entire application, there are multiple of them. アプリのアーキテクチャを全体的に見てみると、それがいくつもあります。And each of those has an imperative shell around it. そしてその一つ一つに imperative shell があります。So the other day, my team and I rewatched a talk titled Advanced iOS Application Architecture and Patterns from WWDC 2014. 何週間か前、私のチームは WWDC のトークを見直しました。2014年のトークです。And I really love this quote from Andy Matushak. All you really know, maybe, is that your taste is improving a lot faster than your ability. 知っているのは自分の好みは自分の技術より早く上達しているということだけかもしれない。And that's where I was with this whole functional core imperative shell idea. I had a taste for it, I had an intuition, but I wasn't sure how to use the ideas in practice. 私もその立場にいました。Functional Core Imperative Shell の理論は理解できたのですが、実際どのようにこのコンセプトを実用化できるのかよくわかりませんでした。And that was fine. To learn something, we first need to develop a taste first. And we need to develop an intuition. Then we can start applying it in practice when the time is right. でも、それで良かったのです。新しいアイデアを身につけるときは、まず先に感覚を覚えてから、後で使えるかなと思ったときに使えばいいんです。And that's what we're going to talk about today. 今日はその話をさせていただきます。We're going to talk about boundaries. 実践的 boundaries です。As I've been writing more and more Swift, I start to see that the concept of functional core imperative shell applies not just to functional programming, but also to good engineering in general. Today, I'd like to show you some of these examples. 毎日少しずつ Swift を書いているうちに、このコンセプトはファンクショナルプログラミングだけではなく、プログラミングいいエンジニアリング全体的に適用できるのが明らかになってきました。今日はいくつかの事例を紹介しながらお話しさせていただきます。The first one I want to talk about is the story of the immutable core and the network key shell. まず第一、不変な芯、immutable の芯とネットワークっぽい表面の話です。So the Venmo app looks something like this. Like any social app, there is a news feed where you can see your friends' stories. Venmo のアプリはこのようなものです。友達のストーリーがたくさん 見られます。You can tap into any of them to see more details. コメントとか見たかったら好きなストーリーをセレクトして見れます。And each story is modeled something like this. So the story has an ID, title, message, sender, recipient, a date, and maybe a few other things. この辺から英語になります。And the story's view controller class displays a list of stories. So it has a list of stories and just presents it in maybe a table view controller. And then when you tap into one of these stories, we show a story detail view controller, which you can initialize with a story. So this is what gets pushed on if you select something in the table. It has, it has a view for the title, a view for the sender, a view for the recipient, and a date label. And then when you initialize it with a story, it creates all these views and sets it to these immutable lets. これ全部ノンオプショナルとイミュータブルだし、結構ファンクショナルなシーンだと思います。So I'm pretty happy with this. Everything is non-optional and immutable. Immutable as a view controller can be. I'd say it's pretty functional of a core. But of course, soon after, we had to add a new feature on top of this. We had to implement push notifications and handle different URL schemes. しかし、もちろん、この結構直後に新しいフィーチャーを足さなくちゃいけませんでした。プッシュノティフィケーションのフィーチャーです。例えば、このような URL スキームに対応して、ストーリーディテールビューコントローラーを表示したり。And so this is what the view controller looks like right now for the detail view. But we have a slight problem here. We can't use the story initializer before, because when we're coming from a push notification, we don't have the story to initialize this view controller with. We only have the story ID. So the first thing that I tried was to add an initializer that takes a story ID. So this seems fine. And then I started implementing it. So the initializer with the story is still the same. 前と同じです。And for this initializer with the story ID, how does this one work? Unlike the case where we come from the stories view controller, which owns the list of stories, we don't have a story to use to initialize all the properties. And we can't set them all to nil because they're all non-optional. So what are we going to do? Well, maybe we could load the story in the view load, but then we have to make everything mutable and optional. And I guess we can initialize it and make everything nil at first. And then in the view load it, and I mean, this works, but I don't know about you, but this code doesn't really suit my taste. Something just feels wrong. Before, everything was non-optional and immutable, so there was only one way to configure this. Now there are 2 to the 4th power, 16 ways to configure the properties. Actually, there are an infinite number of ways since everything is mutable. So I thought about it more, and this is what I came up with. We pulled out the networking code into an outer layer, a parent view controller, called Story Container View Controller. So you can initialize one of these with a story ID. And once you have the story ID in the view load, we can use our API client and load it. And if it's successful, we can create the story detail view controller and add it as a child view controller. And if there's an error, we can show some kind of an error. And now, if we get a URL like this, all we need to do is use the story container view controller, and it just works. So that handles the stories case. But what if we need to handle other URLs? What if we had to show a user's profile from a URL? Or maybe we need to show a specific message from a URL. What if we wanted to make it a little bit more generic? To do this, we defined a new protocol, remote content providing. So this protocol has an associated type content, and it specifies 2 things. First, how to fetch content. So this is most likely an API request. And 2, how to take that content and convert it to a view controller to display. And then we have a remote content container view controller, which is generic on type T, which is of remote content providing. And you can initialize one of these with a provider. And in the view.load, we can use that provider to fetch the content, and then also use the provider to get this, the view controller to present, and add that as a child view controller. And using this, we can handle the stories case. So let's look at what the stories provider would look like. So the stories provider, let's see, in the fetch content, we use the client to show the story and get the story from the API. And then in the view controller for content, in the success case, like before, we get the story detail view controller with a story. And if there's an error, maybe we can use something like an error view controller. And using this, now if we have to handle a URL scheme like this, we can create a story provider with the ID, and then we can use the remote content container view controller using that provider. And then we can do something very similar for the other two things. So for user, you can use a user provider. And then for messages, we can use a message provider. So by pulling out the stateful networking code into a container view controller, we were able to prevent our detail view controller from turning into something like this, where everything is mutable and optional, something just doesn't feel very right. And if you visualize it, it might look something like this. So there's statefulness creeping into the core. The view controller is making an API request to the cloud, but instead, we're able to maintain our immutable and, loosely speaking, functional core, which looks more like this. All the properties are immutable, non-optional. You set them once, and you're done. If you visualize this, it looks something more like this. Much better. The next thing I want to share with you is the story of the independent cores and the connective shell. 独立した芯とつなげる表面の話です。As a side project, I've been working on an app that helps me learn Dutch. 私は今、サイドプロジェクトとしてオランダ語を勉強するアプリを開発しています。One thing that I've loved about this process is that I've get to experiment with a lot of ideas that I've been interested in this brand new code base. 新しいアプリを開発することによって、いろいろな新しいアイデアを試す機会が増えました。その一つはコーディネーターです。One of those ideas is the coordinator's design pattern. I first heard about it last year at a talk given by Sarush at NS Spain. 去年、官郎さんの NS Spain の講演で初めて聞きました。The main idea behind coordinators is that view controllers don't know about other view controllers. メインアイディアは、ビューコントローラーは他のビューコントローラーを知らないということです。So let's look at some code. Let's start with the app delegate. By the way, can we admire how small this app delegate is? The app delegate has a window as usual, and it also has an application coordinator that we initialize using the window. And then all we do in the did finish launching with options is that we create the window, and then we just call start on this application coordinator. So before we take a look at the application coordinator, let's take a look at the coordinator protocol. So I think there are different ways to define the coordinator protocol, but the one I defined is very minimal. All it requires is a start function to kick things off. So let's look at what an implementation of a coordinator would look like. So this is what the application coordinator looks like. So it has a root view controller, which in my case is a UI tab bar controller. And then it has two navigation controllers, one for each tab, and two coordinators, one for each tab, which one of them is for words and the other one is for phrases. And then in the initializer, we create the root view controller, that's the tab bar, with the two navigation controllers, and we initialize the two coordinators with the respective navigation controllers. And then in the start function, we set the Windows root view controller, and we call start on the two coordinators. And this is what the words coordinator looks like. So the words coordinator can be initialized using a navigation controller. And let's see, we set the presenter, we create some sort of data source to load up the data, we also set the list view controller, which is what shows the list of words. And maybe we set a title, and we set the items onto the list view controller so it can show things. And then in the configure cell, we set the item on the cell. So for this list view controller, I read something on Objective-C.io's blog, and they had a really cool blog post on generic table view controllers or functional view controllers. And then in the did select item call on the list view controller, we tell the presenter to push the view controller. So the idea here is that the list view controller isn't pushing anything on itself. It's asking the coordinator to present the view for it. And in the start function, we call push view controller on the presenter with no animation. So what this essentially does is it just sets the root view on the navigation stack. And for the phrases coordinator, it's basically all the same thing. The only thing that changes is that the list view controller has phrases instead of words. So yeah, I totally recommend reading that blog post by Objective-C.io if you're curious about that part. So this is kind of a lot of content, but if you're curious about coordinators, I highly recommend Sarush's talk from NS Spain. It's really awesome. It's in Objective-C, but it's still really, really good. And when you use coordinators, the backbone of your app becomes a tree of coordinators. コーディネーターを使うと、アプリは木のような形になります。If we wanted to add a feature that adds a search functionality for words, we can create a new search coordinator and have the words coordinator manage that. サーチフィーチャーを足したかったら簡単にできます。Words コーディネーターにサーチコーディネーターを足すだけです。If we wanted to add login functionality, that's also easy. We can add a layer right above the, we can add a layer above the word coordinator and phrases coordinator called dictionary coordinator, and that basically manages the tab, the logged in side, which is the two tabs. And then we can have a separate login coordinator that's managed by the application coordinator. ログインも簡単です。アプリケーションコーディネーターにディクショナリーコーディネーターとログインコーディネーターを足すだけです。And if we want to add a sign-up flow, we can add a sign-up coordinator that's managed by the application coordinator. So as you can see, it's really easy to add new features using coordinators, and it's pretty awesome to work with. Sign-up も同じように足せます。このコーディネーターパターン、私結構気に入っています。So this is what it would look like if we had an app that had view controllers present view controllers directly. コーディネーターを使わないとこんなイメージです。But by using coordinators, it looks more like this. The view controllers don't know about each other, and the coordinators handle all of the application flow. そして、アプリのフロー全体をコーディネーターに任せると、こんな感じです。So the view controllers are very kind of immutable as view controllers can be. ビューコントローラーは結構不変、immutable です。And I'd like to stop here and talk a little bit about abstraction. Abstraction is one of the first concepts that we learn as software engineers. When I first learned about abstraction, I only thought about the interface. But as I've started embracing Swift features like value types, I've noticed that abstraction applied just to the interface is not enough. In the first example, with the story detail view, it wasn't good enough to just add an initializer that uses the story ID. Sure, it was a simple interface, but it introduced mutability into what would have otherwise been an immutable core. 抽象化アブストラクションは抽象化アブストラクションはソフトウェアエンジニアとして結構初めに習うコンセプトです。抽象化と考えるとインターフェースが綺麗というイメージがありますね。しかし、Swift をたくさん書いているうちに、インターフェースでアブストラクトするだけでは足りないということが明らかになってきました。And that's why we need to look a little bit further. I'm finding that it's not good enough to just abstract things through the interface. We need to think about what parts of the app make sense to be functional and immutable, In other words, solid. まず、アーキテクチャのどの部分がファンクショナル、イミュータブル、堅実なパターンに適しているのかが堅実なパターンに適しているのかを把握するのが大切です。And then we need to step back and think about how each of those components interact with inherently imperative and stateful things like networking, things that are fluid. And things that are fluid aren't necessarily bad. In fact, they give our apps movement and life. そして同じようにどの部分がネットワークコードのように imperative, stateful, 流動的なパターンに適しているのを把握するのが大切です。The key, which I think is the most difficult part, is finding the boundary between what's considered solid and what's considered fluid. 鍵は堅実さと流動的さのバランスを見つけることだと思います。その boundary、境界を見つけることです。And I think if we frame our thinking around this balance, we can write our apps that are more resilient, robust, and future-proof. そのバランスを見つけることで、より良い、より安全な、そして将来性があるコードを書くことができると思います。I hope that you learned some new ideas today that you can start using immediately, or at least got a taste of what you might want to try in the future. 今日は何か新しいことを習った、試してみようと思っていただければ嬉しいです。Thank you. ありがとうございます。
Hi, Ayaka.
Hi.
Thanks so much for talking about boundaries in practice. That's super important. So one thing I'm curious about is the use of these ideas in production apps. And you were talking about how your first story was used in Venmo. So have you found it easy or difficult to integrate this idea throughout the entire code base? Is that something that you think would be like realistic or feasible? Or have you thought about that?
Sure. 質問は、今日2つコンセプト紹介したんですけど、その最初のコンセプトはsorry. How do I explain this? 通訳するの難しいです。もう今、Venmoのアプリはもう存在してるんですけど、こういうコンセプト、新しいコードベースに足すのは簡単かもしれないですけど、existing コードベース、もうすでに存在するコードベースに足すのはどうやってやっていますかという質問です。I think I translated that okay. I think the answer to that is, so for the coordinators pattern, I started using it in a brand new code base, but after I started using it in a brand new code base, I also started using it in the Venmo code base as well. So I think the brand new code base is where I experiment and try crazy ideas, and if I like it, try to introduce it into a production code base where I shouldn't be experimenting with too crazy of ideas. 日本語では、そのコーディネーターパターンは新しいコードベースにまず使ったんですけど、それでいいなって思ったから、Venmoのコードベースでも使うようにしました。
コーディネーターパターンについて質問なんですけど、現実のアプリケーションの仕様として、画面遷移がプッシュとポップのドリルダウンだけじゃなくて、なんかすごい潜った画面のところで、あるボタンを押したら、その画面の上の方の部分が、なんかスタックが全部消えて、別の画面に根元の方で切り替わるみたいな、プッシュポップじゃ表現できない、根元で差し替っちゃうような画面遷移があった場合って、そのビューコントローラーの関心を互いに排除できるっていうメリットはなくなっちゃうような気がしたんですけど、そういうケースってどういうふうに対処できるんですか？
So the question was, so in my example, it was just view controllers were being pushed and popped and not anything too fancy. But he was asking, what if you're like pretty deep in the navigation stack and you have to show something like up top and also like pop the entire stack and like hide everything? その答えは多分コード見てみたいです。やったことありません。 避けろ My answer is I would like to see that code base and think about it a little bit more because I haven't done that personally.
なんですけど、今のコーディネータパターンは、バイパーでいうワイヤーフレームかなというふうな感じがしたんですね。で、バイパーとやピクチャーのワイヤーフレームでは、ワイヤーフレームごとに参照を持ってて、で、根元までそれを通知して、その根元のところで差し替えるというようなパターンになると思います。
同じような So he was saying that the coordinator pattern is pretty similar to the wireframe part in the Viper architecture pattern. 質問は何ですか？
今の補足で、一応質問もあるんですが、それ、ストーリーボードとやセグウェイとの関係はどうなるのかなと思って。
So he's asking, how does this work with storyboards? And my answer, I think, is that I don't use storyboards because they inherently couple view controllers together. 私はストーリーボードを使いません。ストーリーボードを使うとなんかビューコントローラーが全部なんかお互い知ってるようになっちゃう。カップリングしちゃう。
僕はバイパーでワイヤーフレーム使ってるんで、最初は、ストーリーボードを使わないのかなと思ったんですけど、自分でその完全に繊維のコードを独立させてセグウェイに取り付けるようなライブラリを作って、で、それで完全に、コントローラーから他のコントローラーへの参照をなくすことをやってます。
見てみたいです。
一応 GitHub に上げてあるので。
じゃあ後で見せてください。Yeah, he said that he has a library that uses storyboards but still manages to decouple the view controllers, which is really cool, and I would really like to see that. ありがとうございます。続きは Q&A でお願いします。10時半から11時まで向こうの部屋にいます。ありがとうございます。